All right, in this section, we're going to be looking at content from Chapter 5B. So let's start with number 20, actually 26 here. So we have to find the areas of these triangles. Now, if you forgot, there is a couple of formulas you're going to need to do this. So for the first one, they give you three sides of the triangle. So let's just draw a triangle so we can see what we're working with here. Again, we're just using this as reference. When you're drawing a triangle, you don't have to worry about it being accurate with your different sides. So I'm just going to label them. Remember this, the lowercase letters are across from the angles with the capital letters. So A being 7 would be this side, B being 12 would be this side, and C being 13 would be this side. So obviously here, the side C in my diagram is the smallest side, but it really does, even though in numbers it's the biggest side. So it doesn't really matter if this is real accurate, we're just using it as a reference. All right, so for this one, we're going to need to know the formula to find the semi-perimeter and how to find the area using that semi-perimeter. So the formula for semi-perimeter is you just take and add, because remember, perimeter just means you add up all the sides. So here we're adding up all the sides and dividing by 2. So the formula for that is A plus B plus C dividing by 2. So for this problem, we really didn't need to have the diagram for that. We can just add the three sides together. So when I add the three sides together, 7 plus 13 is 20. 20 plus 12 would be 32. And half of 32 would be 16. So I know that my semi-perimeter is going to be 16. So now to find the area of the triangle, when we're using the semi-perimeter, we're going to take that semi-perimeter and multiply it times S minus A, so the difference between the semi-perimeter and side A, times S minus B times S minus C. Something like this. All right, so for this problem, we would take our semi-perimeter, which is 16, times the difference between, I'll just write it out, so 16 minus 13 times 16 minus 12 times 16 minus 7. So when you go to simplify this now, I'll just tell you, so you could type this all in your calculator, what's under the radical. Some of that you could probably do in your head. But when you simplify it under the radical, we get 1,728. So when I take the square root of 1,728, we get approximately 41.57. So that would be your answer for 26A. For 26B, this one's different. They don't give us three sides, so we're not going to use the semi-perimeter for this one. This one we have a different formula. So let me first draw out our triangle. So let's call this A, B, and C again. So angle A is 47 degrees. Side B is 32, and side C is 19. So the area for this one, we would take 1/2 of two sides times the angle in between them. So in this case, the two sides would be side B and side B, side B and side C, and angle A is in between them. So we take 1/2 of B times C times the sine of angle A. So in this triangle, our sides B and C are 32 and 19. And the angle is 47 degrees. So literally, all you have to worry about is just typing this in your calculator. And when you do that, we get 222.33 degrees, or 222.3. That's the perimeter. Or that's the area, rather, of the triangle. All right, let's look at 27. Another diagram. So A, B, and C. So side A is 2 units, side B is 7 units, and angle C is 80 degrees. So this is a side angle side situation. Remember, when we're trying to solve a triangle, you always want to look to see what type of scenario we're working with, so you know what formula to use. So if it's side angle side, this is where we're going to use the law of cosines. So the law of cosines, you want to look up that formula if you forgot it, but the way that we're going to set it up would be taking the side opposite the angle that we know, which is side C. So C squared equals the other two sides squared added together, so 7 squared plus 2 squared. And then it's minus 2 times those same two sides times the cosine of the angle, times the cosine of 80 degrees. All right, so you just type all that in your calculator. 7 squared plus 2 squared times, or minus 2 times 7 times 2 times the cosine of 80 degrees. When you do that, we get 48.14. And then we take the square root of that, and we get 6.9. Okay, so we found that missing side. Now we got to find the missing angles. To find the missing angles, we're going to use the law of cosines again. Remember, it's always best if you start with the law of cosines just to continue with the law of cosines, or vice versa. If you start with the law of sines, stay with the law of sines. It just avoids every once in a while we have a unique situation where if you're not consistent, you're going to get the wrong answer. All right. It doesn't matter what angle I start to find, so I'm just going to find angle A. So to find angle A, we're going to use, again, the law of cosines. So 2 is across from angle A, so I'm going to say 2 squared equals, and then angle A is made up of the other two sides, 6.9 squared and 7, so it'll be 6.9 squared plus 7 squared, minus 2 times those same two sides, times the cosine of the angle, which that's what we're trying to find out. All right, so now these are a little bit trickier. So I'm going to subtract, now I know 2 squared is 4, but I'm just going to write it as 2 squared for right now. I'm going to subtract these values from both sides, because remember, all of these are being multiplied times the cosine of A. So we cannot combine these with the 6.9 squared and the 7 squared, because we're not working with like terms there, because the rest of that is attached to the cosine of A. So all we can do is subtract 6.9 squared from both sides and subtract 7 squared from both sides. And now we're going to simplify each piece. So the 2 squared minus 6.9 squared minus the 7 squared, that simplifies to be negative 92.61. And then the right side, negative 2 times 6.9 times 7 is negative 96.6 times the cosine of A. So what I would do now is I would divide both sides by negative 96.6 and take the inverse. Let me just do it this way to save myself some space. Then I would take the inverse cosine of that value, or we can do that now. We can take, because we're trying to find the angle measurement. So when I try to find the angle measurement, I'm going to do the inverse cosine of both sides. So if you did this in 2 steps, you could take and divide these together and then do the inverse cosine of both sides. But either way, you end up getting that angle A is going to be 16.5 degrees. All right, so we found angle A to be 16.5 degrees. We found angle, or side C, to be 6.9. So now let's find angle B. So to find angle B, remember we have 180 degrees in a triangle. We knew 80 degrees from the beginning, so now we're down to 100 degrees. And then we're going to subtract from that 16.5 degrees. For that, you get 83.5 degrees. Your measure for angle B. All right, so that is 27A. Let's look at 27B. Now, if you notice I added more space here, it's because we miscalculated how much space you would need for this problem. So the best bet would be to probably work on this one on a separate sheet of paper. Let's start by drawing a diagram. So side A is 125. Angle A is 25 degrees. And side B is 150. Remember, this is one of those angle side side situations. So if it's angle side side, we have to look to see, are there two triangles? So that's what we got to figure out. Are there two triangles? I don't know yet. Tell you when we can figure that out. All right, so the only way to start this problem is by using the law of sines. So you're going to use an angle and a side across from it, and we can use then the other side and angle that we're trying to find to set up our proportions. So I don't know angle B, but I know side B is 150. So I'm going to use that as my other ratio. So we're going to take the sine 25 degrees over the side across from it, which is 125, is proportional to the sine of angle B over the side across from it, which is 150. All right, so now what I'm going to do is I'm going to take and multiply the two sides that are diagonally across from each other, the 150 times the sine of 25 degrees, and divide by what's left over, which is 125. And when you do that, you're going to end up getting, because you're going to get I'm just going to save myself some space here. You're going to get a number and take the inverse sine of that value. And when you do that, you're going to get angle B is 30.5 degrees. So if I just went through that too quickly, again, you take 150 times sine of 25, and then divide by 125, you're going to get a decimal. Take the inverse sine of that, and you get 30.5 degrees as your angle for angle B. Now, here's how we figure out, at this point we stop, because it's an angle side-side situation, so I know that I for sure have one triangle. So this one's going to be 30.5 degrees. So I got to figure out, is there another triangle that exists based on that angle that we just found? And so the way that you find that is we just subtract it. We find its supplement. So 180 minus 30.5 degrees is 149.5 degrees. Well, now, based on this triangle, if angle B is 149.5 degrees, and knowing angle A is the only other angle that we have is 25 degrees, so if I take 149.5 plus 25, we get 174.5 degrees, meaning that there's 5.5 degrees left over for us to be able to have another triangle. So this is going to have two triangles. So I'm just going to make it easier for myself and call it 1. So when we go to make a second triangle here in a little bit, we'll have triangle 2. So let's go do that across the board here. So when we go to find our second triangle, we're going to be looking for the same sides. We'll be looking for side B, so we'll call that B sub 2. And we'll be looking for a side C, so we'll call that C sub 2. And angle C. So we'll have the same things that we were looking for the first triangle, we're going to be looking for in the second triangle. And you'll see how or why that is in just a minute. All right, so let's carry on here. So we know the two angles now of this triangle. So now we can figure out the third angle by subtracting them from 180. I'm not going to write that out, but you know you would just take 180 minus 30.5 minus 25 degrees, and you get that third angle. Angle C is 124.5 degrees. All right, now let's find side C. So to find side C, we can continue using our law of sines there. So we know that this one's 124.5 degrees. We can use an angle and a side across from it. So let's do sine of 25 degrees over the side across from it, which is 125, is proportional to the sine of 124.5 over side C. So to find side C, I'm going to cross multiply. So I'm going to have 125 times sine of 124.5. Divide that by the sine of 25 degrees. So this one, when you do this on your calculator, we get 243.8. All right, so now let's go to triangle 2. Now this is actually going to be a little easier than maybe what you're expecting. So I'm going to recreate, so this will be for triangle 2. I'm going to create a new triangle. Again, I don't really care. I'm using this as a reference, so I don't care what it looks like in relation to the other one. I could take the time to make that more accurate if I wanted to, but I'm not going to bother. So we know, we were given at the very beginning that angle A is 25 degrees, side A is 125, and side B is 150. And remember that we did this work and found the supplement of angle B, so this was for angle B1, was negative. Well, actually, this was just to see if we had a second one. But we found the supplement to be 149.5. So we already did the work to find that angle in that second triangle. So now I can simply subtract those, what I know, from 180. So if I take 180 minus 149.5 minus 25, well, if you remember, we already did that, and that would be, as we said over here, we said that we had 174.5 degrees, and so then if we took that and subtracted that from 180, we get 5.5 degrees. 5.5 degrees left over there. All right, so now let's use that information to find side C. So just like before, I'm going to do the sine of 25 degrees over the side across from it, which is 125. And that's proportional to the sine of 5.5 degrees over the side across from it, which is what I'm trying to find. So to find C, we're going to cross multiply. So I would take 125 times the sine of 5.5 degrees and divide that by the sine of 25 degrees. When you do that in your calculator, we end up getting 28.2 as your answer. So again, this one has two triangles, and you only have to worry about finding two triangles if it's one of those side-side angle, or want to be a little bit more on the edge, we could call it the angle side-side situation. So you look to see if there's two triangles. There's not always two triangles, but remember, you do that after finding the first angle, find its supplement, and see if with that supplement and the other angle that we were given, in this case 25 degrees, see if when you add those together, see if it's less than 180 degrees. If it's less than 180 degrees, you're going to have two triangles. If it's more than 180 degrees, you're only going to have one triangle. So that would be something worth noting and putting on your cheat sheet. All right, let's look at part C here for 26. So let's do what we've been doing. Let's draw our triangle. This is a side-side-side situation where we know all three sides. So we're going to start this one out by using the law of cosines again. So let's just say we want to start by finding angle A. So to find angle A, we're going to use a side across from it, which is 1.5. So it'll be 1.5 squared equals the other two sides squared minus 2 times those two sides. So remember, we have to subtract those from both sides because we cannot combine them with these because they're on the right. Those are attached to the cosine of angle A. So those are not like terms, so we cannot combine those. So the only way to start this problem is to subtract 1.9 squared and 2.3 squared from both sides. So now we can simplify the two sides. When we do that, you end up getting negative 6.65 equaling negative 8.74 times the cosine of angle A. So I would divide both sides by negative 8.74, which gives me 0.761. And so then to find out what angle A is, I do the inverse cosine of that, and I get 40.4 degrees. Find angle B, we're going to have to do the law of cosines again. So it would be, again, we could find angle B or angle C. So I'll just do it in order and find angle B. So angle B is across from the side, that's 2.3. So that'd be 2.3 squared equals the two sides that make up angle B. Whoops. So 1.9 squared plus 1.5 squared. It's over now. Run out of room. All right, so just like we had to do in the previous one, we have to do the same thing here. I'm going to subtract 1.9 squared from both sides and 1.5 squared from both sides, leaving us with negative 2 times 1.9 times 1.5 times the cosine of B. So when I simplify the left side on this one, you get negative 0.57. On the right side, we get negative 5.7. So when I take and divide both sides by negative 5.7 to get the cosine of b by itself, we get a positive 0.1. When we do the inverse cosine of both sides, we get angle B is 84.3 degrees. And now to find angle C, we would just take the supplement or find the subtract 40.4 and 84.3, subtract all those from 180, and when you do that, we get 55.3 degrees. So those would be your three missing angles for 26C. All right, let's look at 28. 28, it says Parker must find the distance from point A to point B on opposite sides of a lake. He locates point C that is 860 feet from point A and 175 feet from point B. He measures the angle at point C to be 78 degrees. Find the distance from point A to point B. All right, so when I go to set this one up, this is a story problem, so I'm just gonna make some water here, represent our lake. All right, so we'll have 2 points on either side of the lake, and the third point on the other side of the, over here. So that's what we're trying to find. We know this side, so we'll just call this A. Oops, call this one B, since B was on the other side of the lake, and this one will be C. Okay, so now let's label it with the rest of the information we know. So the distance between A and C, that would be 860 feet. And this would be 175 feet. And the angle here would be 78 degrees. This is a side angle side situation. So if it's side angle side, we're going to use the law of cosines. So it would be to find x. We would say x squared equals 860 squared plus 175 squared minus 2 times 860 times 175 times a cosine of 78 degrees. We go to simplify that, we end up getting 707,643.58. Take the square root of that, and we get 841.2. So that would be your distance across the lake, 841.2 feet, since we're dealing with a story problem. All right, so this one says a 4-meter flagpole is not standing up straight. There's a wire attached to it, to the pole and anchored to the ground. The wire is 4.17 meters long. The wire makes a 68-degree angle with the ground. What angle does a flagpole make with a wire? All right, so I'm going to draw my flagpole here. And here's the ground. And then there's going to be a wire attached to the ground there. And that wire is 4.17 meters long. And the flagpole is 4 meters. And they tell us that the angle that the flagpole or that the wire makes with the ground is 68 degrees. In order to find, in order to use, or what we need to use to find the missing angle here, is we're going to use a law of sines. But the problem is, when I use a law of sines, I know this angle on the side across from it, but all I know is this other side, the 4.17. So we're going to use a law of sines to find that angle down in the bottom left corner, even though it's not the angle I'm trying to find. But once I know two of those angles, then we can find the third angle by subtracting them from 180. So that's the approach we're going to take with this. So it's going to be the sine of 68 degrees over 4 equals the sine of, we'll just call that missing angle, angle A, over 4.17. So then we're going to cross multiply. So we'd have sine of angle A equals 4.17 times the sine 68 degrees over 4. Let's do the rest of this over here. So when you do that on your calculator, you're going to get a decimal of 0.9666. Take the inverse sine of that, and you get 75.1 degrees. But the question is asking us to find what is the angle the wire makes with the pole? Okay, what angle does the flagpole make with the wire? Okay, so that's what we're trying to find. So if I subtract those two angles from 180, we get 36.9 degrees. So that'll be your answer for 29. All right, so this one says triangulation can be used to find the location of an object by measuring the angles of the object from 2 points at the end of a baseline. 2 lookouts 20 miles apart on the coast spot a ship at sea. Use the figure below, find the distance d the ship is from the shore to the nearest tenth of a mile. All right, so since we know the two angles that are 49 degrees and 38 degrees, we can subtract those from 180 to find that interior angle of the larger triangle. We get that to be 93 degrees. So what we're going to do is we're going to treat this right now as a large triangle. So the first step we're going to do is we're going to find one of the sides of the large triangle using the law of sines. So my goal is to find that side D. Now side D is part of a right triangle. So I guess I could have found the side that I put as X, or I could find the side that's Y using law of sines. But I'm just going to find the side that I just labeled as X. And it'll come together here in just a minute. So again, we're treating this as, ignore that dotted line D and just focus on the large triangle. So I would have the sine of 93 degrees over the side across from, which is 20, is proportional to the sine of 38 degrees over the side that I'm trying to find. So when I do that, I would take 20 times the sine of 38 degrees, divide that by the sine of 93 degrees. You get that side X is 12.3. Well, now, if you notice, we have a right triangle. My goal is to figure out that side D, which is opposite the 49-degree angle. So we can use, since we're dealing with the right triangle, we can use our right triangle trig, where we had SOHCAHTOA, TOA, and you can use that to find side D. So I would say, so this is side D is opposite that angle. This is the hypotenuse. So I'm going to say the sine of 49 degrees equals the opposite side D over 12.3. So to find D, I would multiply both sides by 12.3. When you do that, you get your distance is 9.3. In this case, it would be miles. So that's how you would do number 30. All right, let's look at this last problem, number 31. It says a shoreline runs north and south and a boat is due east of the shoreline. The bearings of the boat from the 2 points on the shore are 110 degrees and 100 degrees. Assume the 2 points are 550 feet apart. How far is the boat from the shore? All right, so the way this one's worded is going to be a little trickier here. So we have a shoreline, so that's running north-south. So let's say that purple line is our shoreline. And then out, so we due east of the shoreline, we have a boat. So we'll pretend that this is kind of an overhead view of the boat. And so that would be due east. So it forms a right triangle then. And then we're going to have 2 points on the shore. All right, so now we got to figure out, well, what angle is what? So the fact that one of the angles is 100 degrees, and the other one is 110 degrees, this angle here is going to have a smaller bearing than this one up here. So that tells me that this one here is 100 degrees, and this one up here is 110 degrees. Well, from that we can get a couple of other angles here. We know that this angle would end up being 70 degrees. Actually, let me do it over here. This angle would be 70 degrees, and this angle would be 80 degrees. And then they also gave us, I forgot to write this in, they also gave us that the distance between those 2 points on the shoreline is 550 feet. So that's what we have. That's all we know. Okay, my goal is to figure out what this distance is here, the distance the boat is directly east from the shoreline. So there's going to be a process. There's a couple ways to do this one, but I think the easiest one would be to use the law of sines. Now, how does that help me? Well, if I could figure out one of the sides for this right triangle, if I could figure out one of those sides, that would help me because then I could use the right triangle trig to be able to find that missing side length. So let's do this. I'm going to just rewrite, I'm going to redraw this kind of odd-shaped triangle here so you can see better what I'm referencing. All right, so we know that this angle is 100 degrees. We know this angle is 70 degrees. And we know this side is 550 feet. Well, from that, we can figure out, so if these two angles are 170 degrees total, that means that this angle down here is 10 degrees. So I could figure out, I'm going to call this side A. I could figure out that side of my right triangle by using law of sines. So I could say the sine of 10 degrees over the side across from it, which is 550, is proportional to the sine of 70 degrees, because that's the side that's across from side A. So to find out what A is, we would cross multiply. So I'm going to take 550 times the sine of 70 degrees and divide by the sine of 10 degrees. So when I do that, we get side A is 2,976.3 feet. All right, so now we know, let me redraw our triangles here. So in this right triangle, we know this side is 2,976.3 feet. Now remember, this side here is 80 degrees, meaning that this side here is 10 degrees. And we want to find this missing length. So now this is a right triangle, so we can do SOHCAHTOA. So let's say if we wanted to use this 10-degree angle, I could say the cosine of 10 degrees equals the adjacent leg, which is x, over the hypotenuse, which is 2,976.3. So to find x, we would multiply both sides by 2,976.3. So when I multiply that times the cosine of 10 degrees, we get our side for x, which is 2,931.1 feet. That's your answer for the last problem there for number 31.